My name is Victor Cassone, and I'm going to be giving a talk on building and testing an app using MVP, and more or less my experiences with building it and testing it. So,
Did you start recording your screen?
oh, hold up.
What's the state?
What?
What's your state at the bottom?
Oh, that's you can like block certain websites for a certain amount of time.
Self-control, that sounds dumb.
Yeah, it's nice when the days you're way too distracted. No control is mine.
Can you just hit the stop button?
No, you can't. Like you can shut off your computer, turn it back on, it'll still be running.
What? So,
It's hardcore.
that at least makes more sense. Yeah.
Right? There's no way to turn it off. So for 30 minutes or however long you set it, you can't go to any distraction websites. So if you want to boost your productivity, there you go. Here's a little tidbit of my talk. That one you got. I also have this cool thing now that we're on it. You can like track all the sites you go to. It'll automatically track all the sites and it can tell you like how productive you're being.
I like that one.
I'm currently into that type of stuff. So there it is. It's called Rescue Time. It's free. I really like it. Enough of that. Cool. All right. So, my talk's on using MVP model view presenter architecture in Android. So, a little introduction. There's my Twitter handle. I don't tweet much, but you should still follow me. I work at Agape. That's great. Okay, so I work at Agape Red, and I've been doing Android for about 2.5, 3, maybe more years, and I've been doing some web stuff sprinkled in there. A little bit of Rails, a little bit of Java Web. Currently working on a Grails project, Ruby on Grails. So here and there I do some web stuff, but mainly I try to focus on Android. All right, so the outline of my talk. So I'm going to talk about architecture and MVP basics. So what is web architecture? What is MVP? What are the components of it? Then I'm going to go into my approach to MVP. So I started a month or two ago, created my own project completely in MVP, and I'm trying to build it out to the end. So I'm going to give you my experience with it and my different components to it. And then I'm trying to make the app fully tested, mainly unit tested, but also some expressive tests. I won't show any of the UI testing per se, but I'll show kind of how I approach it using JUnit. Okay, so what is software architecture? It's a generally usable solution to a commonly occurring problem in software development within a given context. And I bolded within a given context because a lot of times when people try to apply software architecture, they try to make a one-size-fits-all for everything, but there's different frameworks. You can be using Rails, you can be using Java, Spring. There's a lot of different ways to implement a software architecture, but they don't necessarily make sense in each situation. And it's especially important in Android because just because two apps are both Android apps, there might be a totally different implementation of architecture. So it doesn't. So there's a lot of people think there's one size fits all, or when you're first coming into it, you kind of try to find that general solution to everything, and there's really not a general solution. So I'm going to start off before Android. There was architecture, web frameworks for using architecture. Usually they're using model view controller. Framework or architecture. So the easy part with web, or not necessarily easy, but the different part is the flow is more known. So you're going to be given a certain amount of action on the web. You're going to have your index action on the controller. You're going to have your update. You're going to have your new. You're going to have your create. There's a lot more finite range initially out of the box with using architecture on the web. Along with that, it's been vetted and well established for years, so people have been trying it out, trying new things, moving forward as time goes on with the web. And I feel like a lot of web frameworks have kind of settled on MVC, or at least the ones I work with. And along with that, it's well established, so it's built into most frameworks. So when you do a Rails create, when you create a web app, you get something that looks similar to what's on the right with the package structure. Some of these directories are added secondhand, but the models is automatically there, the controller is automatically there, the views are automatically there. So it sets it up very nicely for you to use a framework, and you can just plug and play within the given constraints. So on the right, it's a model view presenter flow. I'll talk more about that later, but on the left is your model view controller. So it's a lot more circular. So you'll have everything going through the controller, but also the view can mess with the models, and the controller mess with the model, and the view and controller go back and forth. So the key thing to remember here is with an MVC architecture, it's a lot more circular compared to an MVP on the right, which is more linear and which you'll see a lot more using Android or mobile in general. So architecture neighbor. So out of the box, there's really no framework support. The only thing they really give you is the layers, kind of the bottom layer. So they give you your views that you can render pixels on. They give you your fragments and activities that kind of help manage the life cycle of your application. But other than that, there's really not much else they give you out of the box to help you structure where your code goes and how your data should flow through different objects. So that kind of makes it hard initially when you first look at an Android app. You want to apply some sort of structured system to it because it's kind of a mountain of uncertainty, and there's a lot of ways to do it. You're kind of left to you're kind of like that paradox of choice where you have so many choices you don't pick any. So it's hard initially because you just see this mountain climb. You're not sure what to implement. You're not sure how to do it. And initially, it's not going to make sense. You're not going to be good at it initially, so it's going to cause some struggles up front. And what I found from personal experience, it's not your first instinct to break it off into different components. So a lot of times, most of my first apps and some of my more recent ones, sadly, you see a lot of classes, some view classes, some fragment classes that hit the 1,000-line code limit, which isn't terrible, but usually you shouldn't shoot for some of your fragments and activities and whatnot shouldn't be 1,000 lines or more. It should definitely be a lot shorter, more concise, more modular. So it's a common trap that you fall into when you initially go into Android is you kind of build out these dot objects, which causes a lot of issues down the road. So like I said, a big problem with using support architecture in Android is you end up with these massive activities and fragments. And the problem with that is debugging takes longer because there's so much more to go through. It's a lot harder to maintain. It's kind of frustrating to look at if you're working with them every day. It's this massive mountain to work with. So yeah, and the problem with that is it's not very testable as well. So you can't run the Android APIs in the JVM, so you can't really unit test these fragments and activities that have these lifecycle calls. Can as time goes on, because the tools are being built for it, but they're always kind of lagging behind. Also with Android, there's a lot of data coming from a lot of different directions. So you'll have data coming from an API, you'll have data coming from your local database, you'll have data coming from your sensors on your phone, so your Bluetooth or your GPS or whatever. So data's coming from all over, and your initial instinct is to kind of just implement it all in one spot in the activity fragments, which isn't really the best way to do it. So the solutions. There's a lot of different ways to skin the cat. So you have MVP, MVC, you have model view model. You have some libraries that people built, like Viper, and Mosby, which is an MVP implementation, but it's a library that you can bring into your project and it kind of sets some stuff up for you. You can go the little Bob Martin route and go with clean architecture. You can try to find a way to implement it within the Android framework. And then there's many other solutions to fixing your architecture problem, and it's kind of daunting at times. But there's a disclaimer to these architecture. There's no silver bullet, so you're not going to find that one architecture that fits in every situation. there's going to be times where you're going to have to rework it and rethink it, partly because the Android framework will change. So within the last year, that data binding came out, and there's a lot of talk about how that's going to change. You're going to change the architecture where you really don't need MVP anymore. You can use more of a model view model. And the moral story there is the Android framework will change, and the way you implement your architecture will change along with it. And also, your architecture itself will change. So just say you started right now implementing some clean architecture, something to break it up a bit. Well, down the road, your requirements might change, your app might change a little, and that implementation might not really apply to you now. So down the road, things might change. So the solution I'm going with is MVPs, which is Model View Presenter. And I'll explain what these components mean. So the big thing, when a lot of people come from web, their first question is, what's the difference between a presenter and a controller? And I try to come up with a good analogy for it. So I think of a controller as more of a coach. So it kind of takes people, puts them over here, and then you get input from wherever the new location is, and you redirect it over here. So it's more of a puppet master of sorts, where it's taking in inputs and displaying them in certain ways. And then I think of presenter as more of like a chef. So an order comes in, the chef itself will grab the ingredients, and then it will put those ingredients together, make it look pretty, and send it off to wherever. So like the ingredients, the data, and the order coming in, we consider the view part of it. So why did I pick MVP? First and foremost, there's a lot of community support around it. So if you just Google Android MVP, there's abundant of articles of different blog posts or different GitHub projects or different example projects that really help you understand it and give you a good baseline to figuring out how to implement it. It's very modular, so you can work on certain components of the MVP and know that you really won't be affecting other things that aren't related to it. It's quick and easy to test, so it makes UI testing very easy because you can run a good chunk of your UI test through the JVM, which is quick and more efficient than testing it manually or doing some sort of UI automator on it. It's easy on the eye, so I like the package structure. It kind of forces you to create a better package structure that's more organized, and it favors composition. That's kind of self-explanatory. So, what is a model? So, the model is the data layer of your application, and the model kind of has the broadest meaning out of all the components. It kind of means pretty much the part of your app that gets data. That's kind of how I think about it. So I have it as a set of interactions within the system in our database that is required for the application. So like I said earlier, in the context of Android, you have your remote data, you have your sensor data, you have your local data, so on and so forth. And your goal is to keep it a POJO, which is a plain old Java object. If possible, once you start dealing with some system sensors, Bluetooth, whatever, you can't really do that. But when you can do, you also have your view, which is responsible for routing user actions and displaying the proper data. In the context MVP, it's usually passive, so there isn't much business logic within your view itself. And in Android, it's going to be your fragments, it's going to be your activity, it's going to be your view. So anything that can display data or display pixels is kind of considered a view. And then you have your presenter. So, like I said earlier, it's kind of the intermediate step. So it retrieves data from the model and then makes it pretty and sends it to the view. And your presenter should always be a POJO. There aren't too many situations where it's not. And what I mean by Pojo is there shouldn't be any Android APIs in it. It should just be straight Java. There's no Android package in that. So I gave you a little example, high-level view of MVP. Apologize for the bad graphics. All I had to work with in Google Slides. But let's just say you have a game of some sort, or not even a game, just an interaction where you have a cloud, a lightning bolt, and a person. So let's just say you click on the lightning bolt. So that action will be sent to the presenter. The presenter will route that to the model and says, hey, is the face lightning resistant? You pass the ID of the person's face. So the model will return false. No, it's not. The presenter will be responsible for displaying distinct actions. So if you display a face bubble and display ouch, and then the screen will consequently display the ouch bubble and the word ouch. So it's pretty simple. A lot of people try to make it harder than it actually is. If you look at it from a high level, this is all it is. It's just routing one way and coming back the other in most situations. So I'm going to talk a little bit about my approach with MVP. So the components I use is I still use the view and presenter. And then I also use a controller sometimes. And the only time I really use a controller is when I need to kind of route different views. So if I just say you have like a master layout and you want to display 3 different views within the same screen, well, I'll put a controller to kind of be the bird's eye view on that to know, to kind of trigger which view should be displayed and say whatever state's associated with it. And then for my model, part of MVP, I use something called Interactor. And the way to think about that is it interacts with the system components. So what goes into the Interactor? There's a local data store, which is anything from your local database, a remote data store, which is anything from a remote database, or your system data, which is anything coming from the phone itself. And these are all separate objects, separate interfaces, and the key here is I only communicate through callbacks and interfaces, which can be kind of annoying, so I'm never directly calling a method from another object itself. There's always an interface that's implementing it that I'm calling. This allows it to be easily mocked later on, so you can test it a lot easier, which I'll show here in a little bit. So what are my views? So I usually use fragments. I use fragments about 95% of the time. Only occasionally I use views. So my goal is to have a minimal amount of logic and a minimal amount of caching within the views. So if possible, I try to avoid doing any sort of computation or any sort of if statements, no nothing, if I can within the view. What this results in is you can very easily test it using unit tests, because if the view is doing nothing, then you don't need to test anything going on with the view. You have to just test whatever the presenter is picking out. So that really opens up a lot of options and it opens up a lot of speed for you testing your UI very quickly. But the result of that is you get a lot of getter and setter. So any type of view you have, any text view or edit text, you're going to have a method call to get the text from it, and you're going to have a method call to set the text from it. So it'd be a little daunting if you have, 10 edit text on the screen for a really big form, and there being 20 different method calls in those situations. So it's kind of bulky, but it's kind of just the way it is. So my implementation of a view looks something like this. I use something called a contract. The reason I do this is it's no more than just namespacing. The reason I do this is for the presenter. I hate writing, if you look at any example MVP project, you always see presenter, IMPL, but it's just more or less a way to make the class names more pretty. There's really no other function outside of that. But then I have a view interface, which implements all my thing, a lot of hiding and showing. So all the stuff that you would want to act upon a view is here. So my presenter, so what I do with the presenter, which I'm currently thinking more in depth about, is I store relevant view information. So So let's just say your view or fragment has a certain state to it. Well, I would store that in the presenter because I think that has relevant data to the view itself. And I don't want to store it in the view, so I store that type of data in the view or in the presenter so I can work with it later on. So what I do in the presenter is I handle view validation. So if certain fields aren't filled out, I'll check for that in the presenter itself. And then if it's not filled out, I'll send it right back to the view to display an error. So what my presenter does is it receives data from the interactor mainly through callback. So I call the interactor, but where I end up calling the view logic from is certain callbacks, so like an on success. I'll create a custom callback of on success and on fail, and then I'll route that back to the view from there. I also validate if the view is still active for any call to the view. So there's a method in the base view I just showed in the last slide. There's a method called isActive, and each view I implemented it on has different logic to determine if you say a fragment is still attached or a view is still there. That way you're not displaying data back to a dead view, which will cause a crash. And the moral of the story is my presenter just trying to make the data look pretty. Just grab it from the interactor, try to do something with it, and give it to the view. So similar to the view the view, a lot of actions here. So you have save player, set state, a lot of to-do things. As you can see, the whole benefit of using this type of system is just having, for this example, player detail presenter. So it just looks nicer like the doing. So my interactors, pretty simple. It just retrieves data from whatever source is on the phone. I think interactors are kind of the data controller. So it will determine if I need to grab it from local, if I need to grab it from a remote database. It'll kind of handle that logic. My interactors, which I've seen implemented in different ways, is unique for each view. So a lot of times, if you're familiar with the web framework, they'll have called services, which just you have a user service, which kind of handles all your user computation. That's really what all your business logic is. And it's kind of a generic user for the user. What I'm doing, which I'm kind of going back and forth on, is I have, for each view, I have an interactor that matches it. And the reason I do that is for caching purposes. So each view might have a set of different constraints for caching the view itself. So right now, my solution to that is just have a different interactor for whatever view there is. That might change in the future, but we'll see. And lastly, my interactors have no direct access to a data source. So all my data is through data store objects. So I'm not going to query SQL. I'm not going to do the API from there. I'm not going to use retrofit. I am merely just calling the specific data source I want to use, and then I'll let that handle it. So like I said, here's my data sources. So I have a local data store. This is all my SQL. So it's the interface with the database. It's where all the SQL logic lives. And this is really nice because you can kind of like pull it out and test it separately, and no other part of your app really gets to see it. So even if you wanted to change your database from SQL to NoSQL, you can just essentially pull out this component, change it, add a different database to it, and plug it back in, and no other part of your application will know difference, which makes it really nice and easily testable. My other data store is remote data store. So it's my interface with the API, and this is where all my network callbacks live. And lastly, just any sort of system data I need to process will go in the data store. So I was going to dive into some code a little bit. Just kind of, I'm not going to like go too deep into it. I'm just going to show you essentially what it looks like, what to expect in a real world example. Because a lot of this stuff is theoretical. So I kind of wanted to show it in the wild. So the app I'm working on is an app for tennis players. You really don't need to know the context of the app itself. But I was just going to go through real quick and kind of just show what a typical view looks like. So as you can see here, logic is try to avoid it, but sometimes you just can't. Sometimes you, like for in this case, I don't want to pass back a certain ID for visibility because that's going to end up triggering, unless I have the exact ID, it's going to put in an Android package in the presenter, so I don't want to pass back the actual visible or whatever. So what I do is I just have is editable, and I go from there. But the big thing here is just seeing all the getter and setter. So the methods in the view are just very simple. It should not be more than 5 to 10 lines. It shouldn't be more than a few lines. So it should just be very quick and easy. And this will make it a lot more testable, which I'll show down the road. And then I have my interface, which is essentially, implementing the view, same as the other one. I don't know if you guys can see this. So yeah, a lot of getters, a lot of setters, all that fun stuff. In my presenter logic, so I'll just give you this save player as an example. So I get the first name, I get the last name, and I do the validation there in the presenter. And then through the interactor, I grab a current player. So that checks if there's a cached player, and if there's no cached player, then I'll spit out a new player. And then I set all the values here, and then I plug it back in through the interactor. And this was the callbacks I was talking about. So once these callbacks are called, you check if the view's still active. If it is, save it. If it fails, display something on the view that lets the user know it failed. So as you can see, it's very modular. The methods aren't long at all. It's very nice to work with. And then let's just do the save player example. Right now, it would be a lot more complex. Right now, I just have local data store. It'd be a lot more to it if there was a remote data store. In this situation, I just call this player local data store, and I save the player. As you can tell, it's just an interface. It links to the data store, and if it's success, it trigger one part of the callback. If it fails, it trigger on the failed part of the callback. So, and then I'll dive into my local data store, and this is the downside. Interfaces all the time. So it's simple. So I'm using VDAO as my backend. It's just an ORM that handles like SQL. So yeah, pretty simple. So I can just worry about database stuff here. I don't worry about anything else. But really don't want to get in the nitty gritties. Just want to kind of give a general feeling of what it would look like on it.
Do you have an example of interacting with the system sensors
I don't. No.
Like how would you, let's say hypothetically, deal with something that needs access to the fragment or activity? You would just, I guess you can have access to the activity and fragment in
So like a GPS,
in your
updated
model?
GPS location.
Yeah.
Yeah, in that situation,
Would you put all that in
It's
a
kind of
view, or would
if
you
you
put all
can-
that in a, you say it should be in an interactor, but I don't know how you put it in there.
yeah, some of them you can. I mean, it's not a one size fit all. But if you can, all you need is a context in it. You can pull it out and put it within the interactor. But for like GPS, when you need a callback, it's a lot harder. I haven't played around with that too much. It's more in the theory phase. I was hoping to have more of that for this presentation, but I don't. But if you can, put it there. If not, you'll just route it through Zenner. Cool. So yeah, that was just a quick example of what it looks like and how nice it looks. So that's the basics of how I approach the MPP part. The testing part is really where you see all the benefit. So testing in Android has been behind for the longest time. It still kind of is, because in the early days it was very straightforward. There wasn't much documentation on it. You weren't really sure like how you go about it, and it was kind of a pain, and you're lazy and you don't feel like doing it. So it's an ongoing theme in Android to really not have them test. But it's getting better as time goes on. It's getting do testing on Android, you mainly do it through UI tests. So you use something like Espresso or UI Automator or something that will manually boot up the app, click buttons, navigate the screen, so you tell it what buttons to click, and you pretty much ask the testing framework, hey, is this text you displayed in this text? Okay, pass. The problem with that is each one of those tests takes, I don't know, a couple seconds, takes 5, 10 seconds to do something simple as, log into the app, type some text, click save, see if whatever needs to be displayed. That's just a simple test. It takes way too long, so just imagine if you have 100 of these. It'll start taking a lot of time. So, like I said earlier, the problem is you can't use JUnit on the Android package. You can't, there's libraries out there that help assist this. There's one called RoboElectric, which is really nice, where it essentially mocks the Android framework itself. So you can run Android through unit tests that are really fast. But the problem is with that is in the past, it's a lot better now, but in the past is kind of wonky and it's hard to get going. And along with that, it's always going to be a little behind. So like the new, when 24 comes out or 25 or whatever, it's going to always be a lag behind that a little bit because it has to play catch up the whole time. So it's constantly in the state of playing catch up. So you're not going to have the latest and greatest to work with. But it's still a really great tool and I recommend checking it out. And lastly, most people I talk to that work on Android on big apps usually have a QA team. So it kind of discourages people from writing more tests itself because why test it? Why do UI tests when someone's just going to play around with it and test it? So testing the MVP. So I really like testing because you essentially can test your UI through the JVM. So as I explained earlier, the views are really dumb and the presenter spits out all the data that you need to know that you need. So you can essentially test or through your tests, your JUnit test, you can see if the presenter spit out the proper data. And if it did, you know for a good amount of certainty, or about 100% certainty that text will be displayed on the screen. Because you really don't need to test the Android framework itself, because you're assuming that people at Google are doing that before they ship it out. So you need to test that the text view can display text. It's just an assumed feature of text view. So that makes it very nice, and the amount of Espresso tests you write go down because you're testing a lot of your UI components. There's only a few Espresso tests, so just say you trigger alert dialog, well, you want to test to make sure that alert dialog displays. You'll do stuff like that, or make sure you're on the proper screen, or the just general flow of the app type test. Kind of just go through, make sure this button takes you to this screen. There's a lot of general tests when it comes to Espresso and using MVP. And as you'll see, mocking is very important. It really allows you to test it easily, and that's why I use interfaces for everything. That's why I don't communicate with the class itself, because it allows you to mock a lot more. So what happens when you test views? So most view testing is taken care of through the presenter. And like I said, all you need is a few RoboElectric or Espresso tests to get the job done. There's not really too much work you need to do to test a view. Testing presenters, the kind of flow, the flow usually looks like you set up return data from the mock view and or mocked interactor. So what mocking essentially lets you do is it lets you take an interface and it lets you say this method calls and return this value. Or and then it lets you test how many times a certain method is called. So you essentially set up views to return and interactors to return specific data. And then you test if the presenter is doing what it's supposed to do. So after you mock that, you perform the presenter action, and then you verify the proper method is called. So like I said earlier, the view has very simple logic, so you can test method calls. It's kind of bad. I've talked to some people, they don't like the idea of testing purely method calls, because usually you think testing, you think of just testing business logic and is calculating things correctly and whatnot. But in this situation, it's not a huge deal because you know your method calls are directly linked to the data itself, displaying the data itself. So it shouldn't be that much of a concern. So testing interactors, what you do is you just mock your local and remote data stores. You trigger your interactor interactor action, and you verify that it did what it's supposed to do. So it's kind of like a presenter where you mark your inputs and outputs and see if proper methods are called. A lot of times with interactions I'm finding is you are testing method calls more than computation. In this situation, I like it less than the presenter situation because it doesn't really tell you much, but it's definitely better than not having it. So testing your data store. So you don't want to test the actual API. You're trusting your web team to test the API and make sure it works. You're more or less testing the handling of stuff coming back from the API. So don't worry about making sure that you get a list back or the API works. That's the key there. In local, you can set up a test database. I don't have any experience with this. That's one thing I haven't got to yet, but you set up a test database and then you feed it data and then you test your local data store to make sure it spits out from data. Cool. So I was just going to show you run through some examples in code. So so I'm just going to run through a few, kind of give you an example of what mocking looks like. So the library I'm using for mocking is called Mockito. It's very nice. I highly recommend it. I love working with it. So you have, so your tests live within this test package, and not the there is tests in the Android test package, but all your JVM tests are going to be in the test package. And you go down in here, and you go to your whatever test you're going to use. So you have this before annotation. So before each test is run, this before annotation is going to be called. Yep. Try it. This. All right. So every time before your tests are going to run, is that better? Before your tests are going to run, each test, this before method is called, that's annotated with before. In here, you set up your mocks. So you scroll up, you add this mock annotation to your items here, and I label them as, I always put mock in front of them just so I know what they are. Right now, that really doesn't do anything, but as you go on, you'll see the benefit of it. What it doesn't add anything at this point, but you'll see. So then what you do, I'll start with the interactor here. So you'll start with, then you'll declare your interactor class itself and pass in the mocked object. So in this case, it's the local data store. And then you'll set up any other data that you need for your test. So I'm going to show you two tests. So this is a method on Mockito, which it essentially tells this mocked class to spit out a certain, tells the mock class to spit out a specific data type or data value. So in this case, I'm saying when this method is called, getPlayerWithID is called, with any long value in the parameter, then return a null value. So that way, anytime the message is called, you're getting null. So when you go through, then you call the getPlayer on interactor, which, as you can assume, it gets any player. And you pass in any long value, so it doesn't matter what long value is passed in, or just any random long value. And then you pass in this mock load player callback, which uses this thing called time. I guess. Yeah. So you just mock that, same as anything else. And then you call that method, and this verify method is also is part of Mockito. So what you're essentially doing is verifying a method is called so many times. So you're verifying the no player variable is called once. So that way you know, okay, it didn't treat it as like a player is there. You know that it treated it as an invalid player. Or a load callback on a valid player. So you do the same thing. You set it up when get player with ID on any long call, then return a player that was specified in before, and then the setup method. So then you trigger this interactor method with this mock callback, and then you verify that the return value of that callback itself is the player that you passed into this win method. So that tells you that the proper player is being spit out when you call that method. So yeah, I kind of flew through that. Do we have any questions on mocking this so far? Okay, so I'm going to move over to the presenter test. So this is where I really don't like, this is where it's kind of shaky, is with interactors, is I'm testing a method call, I'm not really testing data being processed, which I don't like. So as time goes on, I'm going to figure that out more and more. So I'm going to go through some presenter tests. This is where it gets interesting. So you have your typical setup, so you tell it to recognize all the mock annotations. You declare your presenter, you pass in the mock detail view and the mock detail interactor, which are specified up here. And then this is just a generic thing. I'm making sure that the view is always active, so when that is active is called, make sure it returns true. So I don't have to deal with it being inactive for these set attacks tests. So similar to before, you say when you get a player's first name, you return that value. Well, firstly, this is a test to make sure that first and last name is filled out. So you set the first and last name return value on the mock. You return, you set up the interactor get current player to return any new player. But then you call the presenter action save player, and you verify that save player was never called. So that tells you that the player is never saved because the presenter did its job and picked up on the fact that the first and last name was invalid. So we'll move through another example. So I have a view states in my presenter. So I'll initially set up the view state, help the player detail presenter, and the state is new. And then I have a bunch of visibility setters. So I'll set the view state new, and I'll make sure that these all are proper visibility. Because in the view class itself, it's a very simple method. If it's true, then make it visible. If not, make it visible. So it's a pretty simple UI test here, so I can just essentially test if it's spitting out the right thing, and I know the view is treating it as it should. So yeah, you go through here, and you just make sure those are all called once, with the proper values in them, and you assert that the state of the presenter is what it is. Lastly, so you set up, so you have the mock detail view, get player, you return the ID, then you call the presenter action show player, you verify that the interactor get player returns a player, and I'm not really going to get into what these captors are, but they're essentially a way to feed in data to a callback itself. So then you set up a player right here, you tell it to return this value, and then you make sure that the set, first name, set, last name, and set is right-handed are called. So you know that those are just been with you. Yeah, so kind of went through this quickly, but you kind of get the gist of it, is you mainly use the win, you mainly use the verify. You shouldn't, in the item you're testing, you shouldn't mock. I've seen this before, you mock the presenter. In this situation, I'm testing the presenter. I've seen situations where I mock the presenter itself. You should never do that. You're testing it, so you should declare it as new up here. So pretty simple, pretty quick. And when you run the test, it's really fast. I can test all my tests in a matter of seconds, like 30 something. That's what happened. Anyhow, get to this. So, wrapping up here, so things I like about MVP, it's very readable, especially the package structure. also the class themselves, the methods end up being smaller because you're using it, which I like, and it makes it a lot more readable, a lot more maintainable. And testing is way easier. Testing is something I never really did in the past, but once I started using this, I felt more inclined to do it. It was a lot easier to do. Things I don't like is, so I'm using interfaces for everything. It's kind of a pain to navigate your interface all the time. So you kind of have to go up into the interface itself and go back down. So you're kind of going up and down a lot. There's a lot of, so if you want to do something very simple in your view, you have to make a call to the presenter and then make a call back to the view. So it's a lot of, it's two steps when you feel like you can just do it one there in the view itself, but sticking with formula MVP, you need to call the presenter and call it back just to keep consistency. Like I said earlier, you're testing method calls a lot of times. With a views, that's fine, but with anything else, I don't know if that's good practice. And anytime you want to set up a new screen, you have to create a lot of different classes. So, say when I created a user detail, I would have to create, using daggers, so I have to create a module, I have to create a presenter, I have to create an interactor, I have to create a contract and the interfaces and all that good stuff. So, definitely it's a lot more setup time for any new view. And then tools I use, Mockito, JUnit, Espresso is the automated UI testing, RoboElectric allows you to essentially do UI unit test, Dagger for dependency injection, and ButterKnife for finding views. And yeah, that's all I have. Longer than I thought. So yeah, anybody have any questions, concerns, comments?
I'm wondering, since you've used it a bit, do you find abstracting the presenter behind the interface to be overkill? Because unless you have an example, I don't know when you need to mock a presenter, and that's kind of the big advantage I can see with putting things like the view behind the interface makes a lot of sense. But you're not going to unit test the view, so if you're doing view testing, you're probably using Espresso, which doesn't do one presenter.
I mean, that's a good point. And in my experiences, I haven't needed to mock a presenter.
And I mean, I've seen that pattern. That's how Google's CodeLab thing has theirs. They have that contract deal with the presenter interface as well. I'm just wondering if it's.
Yeah, I'm trying to think. Because there really isn't going to be a situation where your presenter is going to be in your interactor itself or in your model layer. So I mean, that is a good point. I guess I just do it more or less.
How do you? So do you have a provider method for it in your modules, or do you instantiate it in your view module?
I have provides.
Okay, so you have to do that.
Yeah. So maybe I can go without it, but in the future I'll probably just keep it just because of consistency.
Where do you handle app navigation? So like starting a new activity.
Yeah, that's something. I mean, like I said, the architecture evolves over time. You add and take away components as time goes on, and that's one of the next things I really want to add is a navigation manager. You just inject right into the view itself, and you can do all your navigation through there. But as you see in the presenter, there's a few methods that are just handle navigation itself, and I think it's the best practice to abstract that out, take that out from the presenter itself. So right now I'm doing it in the presenter, and that results in more logic in the view. So I can't really handle a lot of that in the presenter itself. So I pretty much send it back to the view, and say handle it in the method, which can do a lot of UI stuff. But as time goes on, I think the best approach is to take it out to that navigation manager.
This MVP framework is typically Android application, not for web.
I haven't. I mean, I'm sure you could use it in web. I haven't seen it in web anywhere. I usually see, at least what I work on is MVC.
Yeah, most of the frameworks are MVC. You can integrate something.
Say that again.
Most of the frameworks can be used for web. Android layers of being MVC, they're all one and the other. They're not MVC.
Yeah. Like I use Rails, use MVC.
Yeah, I mean, they're not MVC. Is there any framework if you know?
I don't. I mean, all I've seen is I don't know if you really can use MVP on the web. It's just there's a lot of communication between the view and the model itself, and MVP really doesn't lend itself for that. won't use controller. I think they have like controller objects, right? Is it set up well for testing? People use iOS. I haven't used